Okay, there's that. Right to go, Jen? Beauty. Okay, good morning, everybody, and welcome to today's webinar, Boosting Pasture Resilience and Soil Security with the SOILKEE approach. My name is Aaron Fay, and I'm a Regenerative Agriculture Officer here in the ACT Natural Resource Management team. And I'm joined here today with my colleagues and Sustainable Ag Facilitators, Jenny and Mary, as well as Jared Roosh and Luke Hush, which make up the rest of the Sustainable Ag team here in the ACT government. So this webinar is brought to you today with the support of the Department of Agriculture, Forestry and Fisheries programs. So that includes the Australian Government's Climate Smart Ag program, as well as the implementing the National Soil Action Plan and the Sustainable Agriculture Facilitator program. I'm coming to you today from Canberra on Ngunnawal land, and I would like to acknowledge the Ngunnawal peoples as the traditional custodians of the ACT and recognise any other families and connection to the lands of the ACT and region. I acknowledge and respect their continuing culture and contribution that they make to this life of the city and region. I would also like to extend that out to any other Aboriginal and Torres Strait Islander people joining us today. So before we begin, just a quick bit of housekeeping. So as I mentioned before, this webinar is being recorded and we will be able to send out that link to the participants after this. And if you could please just keep your microphones on mute during the presentation, we'll have some time at the end for Q&A. We also encourage you, if you have any questions during the webinar, to type them in the chat. So our team will get to them, we'll record them and then bring them up at the end of the Q&A as well. If you have any other technical issues, just let us know through the chat. So we have a jam-packed webinar today with some exciting speakers who will be taking us through the science and practice of regenerative agriculture, exploring how multi-species pastures and the SOILKEE system can boost pasture resilience, build that soil security and contribute towards whole farm productivity and resilience. Our three speakers today bring a diverse range of expertise and experience, and they will be contributing today to today's discussion from different but complementary lenses. Our first speaker is Niels Olsen, a Victorian farmer and innovator behind the SOILKEE Renovator system. After years on working on his family farm and witnessing the limits of high input fertilizer dependent systems, Niels set out to rebuild soil health from the ground up, adopting a soils first philosophy in his management, and together with his family has seen dramatic improvements in soil structure, water infiltration, pasture productivity, and long-term profitability and resilience in his farming operation. Niels will be sharing his journey transitioning towards regenerative agriculture, the thinking that led to SOILKEE, and lessons learned in integrating that system with his grazing operation. Our second speaker, Phil Mulvey, is a soil scientist with decades of experience in restoring degraded land to productive use. Phil has founded several companies operating in the US and Australia, specialising in regenerative agriculture and environmental consulting. Phil is passionate about landscape repair and the role of regenerative agriculture in achieving this goal. He has a focus on teaching techniques to keep the water in, on and under the landscape to build that soil health and soil security in farming systems. Phil will set the scene today by touching on the importance of soil health and the small water cycle, as well as the role of biodiversity in both our soil life and plants to drive that productive and resilient landscape. And finally, we'll hear from Hamish Hunt from the Impossible Dairy, another Victorian farmer and industrial chemist who has helped reshape the dairy industry and how they think about biodegradability, chemical inputs, and soil and microbe interactions. Hamish, along with his daughter at the Impossible Dairy, have been trialling and testing the SOILKEE system over multiple seasons in dryland conditions, and will share practical insights into the pasture performance and whole farm impact that they've seen. So thank you, gentlemen, for joining us today. Really looking forward to this. And I'll pass over to you, Niels, when you're ready.
Yep, thanks, Aaron, for the introduction. Probably leave the science to the next two speakers and just my story and how I came up with the method of sheet composting whilst planting seeds which enables us to plant multi-species into pasture because we're only disturbing about 17%. Now, the reason that I came up with this was a Dr. Arden Anderson seminar that I went to, and he was planting crops of maize in the Mexico desert and having unbelievable results in 5 or 6 weeks of growth. He was achieving 2/3 the protein at the maize at that age. So I thought I'd bring that back to my farming system. And I was really struggling with conventional seeding systems. You can't really plant maize seeds direct into the soil with the competition of the pasture there. It was lucky to get 150, 200 mil high at times. Like, it was very slow. So that was the thinking of coming around that competition-free seeding system, and that's what created the SOILKEE Renovator. The reason that I got into thinking about looking at Arden Anderson was the heavy inputs of conventional fertiliser, which I actually probably was overdoing it quite a bit on the farm, and got to the point where I was restricting my growth severely over that dry summer period, because I'd applied probably double the conventional rate for a couple of years, and really restricted my growth as soon as the moisture got a little bit restricted. Looking into it further, because I did do a farming apprenticeship in ag when I first left school, had a bit of an understanding of the functions of nutrient cycling and really available nutrients, and applying fertiliser to keep enough available nutrients to grow your pasture. So the main input was nitrogen fertiliser, and the heavy applications of that over a couple of years on a very acid soil actually nearly stopped my pasture growing. So that's what got us into this in the first place, learning all this stuff. So once we developed the SOILKEE, it was a real sort of eye-opening response with virtually no inputs at all, apart from a bit of seed running around the paddock. Now, that really opened up a new thinking of what's possible with the feeding of the microbes with the sheet composting system, and the results that we've had at increasing productivity, profitability on farms. Like, we had a field day last week. One of our farmers that has been actually 4 years under our system has said the last 3 years his average increase in profit was 10% per year. So very happy farmers, and he's not the highest one that's increased their profit by a long shot either. So there's lots of that happening with long-term results at the moment. So it's actually building now that the long-term results of building the soil biology in your system cycles the nutrients and keeps your fodder growing, keeps your moisture in your soil for the plants to utilise, and gives you longevity. But the system that we've been applying, it's not a lot of input, which is sort of upsets a few people that are relying on inputs and their understanding. So this research that we're doing up here at Canberra is groundbreaking in what we're looking to showcase and support the knowledge and understanding of what these farmers have been doing 4 or 5 years on their whole farm, and actually achieving great financial results. So if we can get some more learning on how to, which really brings us to the science of it, which is that have been around us for a while now, Phil and Hamish. They really taught me a lot of how these things are functioning and working, and we should be able to improve it even further again. So yeah, that's sort of the rough picture of where I'm at and what we got up to. Thank you.
Thanks, Niels. And just to let everybody know too, we're holding a demonstration day on the 23rd of March, where Niels, Hamish and Phil will be all coming up, and they'll run us through a physical demonstration of the SOILKEE and sort of continue this discussion around these concepts. So Phil, when you're ready, if you could share your screen and presentation and take it away.
Okay. Hopefully that has come up in presentation mode. Terrific.
Yep, seeing that one, brilliant.
Thank you very much for the invitation. It was in some ways a flattering invitation, and I do appreciate it. I'd like to pay my respects to all elders, past and present, who have nurtured and repaired land. And that's we as a group have come together to actually continue our education in that respect. So I'm going to give a little bit about what I know, and I look forward to learning from the observations and practice of those based in farming in the Canberra district. So
Phil, do you mind just, I think, hitting from beginning, just on presentation mode?
yeah, it should be on presentation mode. There we go. Excellent.
Yeah, beautiful. Thank you.
Thank you. Let me just start with a couple of landscape issues. I gave what was a 2-hour talk on looking at the flood at Yagara, and it was a deadly flood. It came in very, very quickly, much quicker than predicted, rose higher than predicted, but was only the 6th greatest rainfall event. But the flood was by far the greatest and the fastest. To publish in Science is considered the top journal in the world, and less than 0.1% of papers get accepted. This paper got accepted, and I was a bit surprised because it investigated the river floods, the hydrology and the response of rivers after the drought, and looked at what a 2-stage response is. So those red areas indicate that the baseline flow did not return after the 2007-2008 drought. Interesting enough, the authors called it a hydraulic drought that extends beyond the drought. But they didn't actually go further. They couldn't work out why it occurred. But if you overlay that on Silurian soil or soil derived from Silurian, which is where most of the gold rush material occurred, you'll see there's a very close association between dispersive soils and this hydraulic drought. The data on Lake Eyre is very, very interesting. Lake Eyre has filled to 2 metres 8 years in the 100 years from 1884 to 1984. If you include this year, it will have filled 12 years in 40. And interesting enough, the 2021 and 2022 years, and everyone sort of understands that sea level is rising. Well, what you're not told is about 60% of the rise, and it's only small, about 1 millimetre or 2 a year, 60% of that rise is water coming off the land at a greater rate than it used to. So in 2021, 2022, the hydrologists noticed that the world had fallen 1 centimetre in sea level a year for those 2 years, where previously had gone up 1 millimetre. And they looked further and they found that El Nino had resulted in the only inward draining basin of the world taking sufficient water out of the system that drained inland to actually drop the levels. But in amongst all that, we've actually got the southern part of Australia and up a little bit on the both east and west coast is actually dropped by roughly 20 to 30% rainfall. And if you overlay that and even look at Tasmania and the Western wheat belt, it actually directly coincides with mixed farming and cropping areas, directly. Tasmania is very clear, and so is Western Australia. And that little bit down at the bottom, close to the bight, that appears to be only slightly affected, that's actually native forest, uncleared. So you're dealing with some interesting impacts here. So let's now look at extreme hot days. So an extreme day is defined as a day in which the daily mean temperatures are the warmest 1% of days of each month. And that speaks for itself, because people think climate change is just 1.5 degrees change in the mean global temperature. I mean, what does that mean to us? Next to nothing. We can't understand that. But this we can understand. So here's looking at fire events. So central and eastern Victoria are 2% of Australia's landmass, but receive 28% of our significant bushfires. That is over 100,000 hectares or has a death. The A and Bs, the blue line and the infilled blue line with sort of an orange colour, that's when the MIA opened stage 1 and B stage 2, and that's 15 years after the MIA opened. It's just worth noting. So this is a presentation about the water cycle, particularly the small water cycle, is broken. We'll talk about what a water cycle is. We'll talk a little bit about, tiny bit about landscape health song and what you can do to amend the small water cycle, just a bit, and an introduction to the impact of aggregation and how to go about creating a sponge. This is just an introduction. So I want to start with farm families. My wife is a 5th generation farm family. I am a townie from Mudgee. So I certainly know a lot about farm families. I did an ag degree. Farmers want to be sustainable. They care about the land and they adopt advice given. And the advice given by Department of Ags and CSIRO has been delivered with the best intentions. It was done to improve productivity, but it has come with huge unexpected consequences. And going forward, we now have the science to actually, and the practice to address those unexpected consequences. I need to talk briefly what I consider the primary climate forcer. And that is not actually greenhouse gases. So a tiny little bit of physics. Solar radiation comes in with a broad range of radiation, of which infrared is a tiny component. A large portion gets reflected by the clouds, so clearly water has a major impact. That gets through the clouds comes to the land, and 95% of it that hits the land does one of two things. The other 5%, 4.5%, goes deep into the earth, and 0.5% goes to photosynthesis. But the 95% that hits the land, it gets converted to either what's called latent heat or sensible heat. And latent heat is the heat required to change a state, i.e. from water to gas, such as evapotranspiration does. And sensible heat is the heat that is absorbed into the medium and causes all the atoms in the medium to vibrate. And the only way they can settle to their preferred state is to release infrared. So how those heats are converted from solar radiation has a huge impact. So let's just briefly talk about the small water cycle. The small water cycle is within the big water cycle, and it is water that comes from the local area. 40 to in the water cycle. In the equatorial zone, it's as much as 95%. Once you get into the desert region, it drops to the range of 10 or 20%. So the large water cycle decides where the clouds come over. The small water cycle decides whether those white clouds go grey and how much of them is pulled down. So you need the two working together, but you can have, from the water that comes from the ocean, it cycled over land numerous times. In fact, all water below, beyond about 800 kilometres inland is actually moved inland by a thing called the biotic pump, i.e. evapotranspiration. So it's the small water cycle that rotates inland. Canberra is within the zone that's primarily impacted by the large water cycle, but the rains from the south are more than 600 kilometres inland, and therefore that's the small water cycle rotating onwards. Those of you who farm for a long time might remember the winter mists and light rains that you used to get, which in many instances you don't get anymore. So the small water cycle is the local rain. It's responsible for 40 to 70%, as we said. It's responsible for the dews, the fogs, the mist, the soft rain, the small raindrops during winter, and the large localised summer thunderstorms that you can still build up locally and deposit locally. And hence, it, as we said, magnifies that large water cycle. But what it actually needs is an opportunity. And the further in it moves, the more extreme, responding simply to the water of the landscape. Graze and farm, we reduce the cycle to get in, and we increase the extreme events. And the introduction of that talk was just looking at the extreme events. So to lose the small, we have, and that heat from the irrigation areas has had a huge impact down in central Victoria. We reduce the rain, particularly the reliable rain. We increase extreme events. We increase severity of bushfires. We depopulate rural regions. We usher in deserts, and every civilization has collapsed because of this impact. So what we now know, climate's primary force is water. How we have managed hydration of our landscape stops or reduces the small water cycle and increases infrared release from the land by up to 7 times. I just repeat that, by up to 7 times. So the greenhouse gases are actually the blanket that ensures that heat comes back. It's not the source of the heat. Here's an example from Slovenia. It was published in 2007. This has been well known by hydrologists and some climate scientists, and soil scientists for many, many years, that greenhouse gases are not the primary climate forcer. So here's an example from Slovenia. It was published where you've got a drained, or we have what's known as water meadows, and you've got 2 properties about 2 kilometres apart. One actually hasn't drained their water meadows and gone for cropping, and they have where they graze their water meadows during late summer and summer. So in late summer, these water meadows are producing 70 or 80% latent heat and 5 to 10% sensible heat. A couple of kilometres away, the measurement found over a paddock that had just been harvested, that there was 60 to 70% sensible heat and 10 to 20% evapotranspiration. So you can see this is a 7 times increase in infrared, in sensible heat leaving the land. So droughts are obvious, of course, but what about floods? Because, clearly that sensible heat stuff, small water cycle, could easily explain that. But the floods are a relationship of the land to the rain. So what you've got when you look at a flood, and when you look at Yagara had a flood peak like that in Orange. Sorry, it's because it's close to Orange, I'll be careful, but the indicator there in light brown as opposed to orange. And so what you had there is a very sharp response, and it was much sharper than it had been in 1953 when the rainfall was bigger. And it was much sharper because in the last 70 years, the use of land around Eugowra in the upper catchment had moved from mixed farming to 80% cropping. And the 80% cropping had deaggregated the soil, and the soil was mostly again on this Silurian mudstone, but it was on a little bit of white granite as well. There was some basalt in the catchment, but that was mostly associated with the rivers, and there was some alluvium in the catchment, but the upper catchment was in a fairly friable soil. They had deaggregated with the constant cropping. And heavy set part grazing will also do a similar thing. Deaggregation means in that soils, even though the granites were slightly sandy, they had a situation where the fines were infilling the pores and the rainfall event was very heavy because of the association with the small water cycle being absent. So you had a situation where you got heavy raindrops, which seals the surface, that gets maximum runoff. So we had maximum runoff, and you had no alluvium capable of absorbing it because you had incised rivers, and you had this impact that was very quick, very sudden, very high. Unlike the previous landscape, which had a baseline flow, it took a while to come up and it took a long time to come out, which meant there was storage in the soil and storage in the alluvium. So if you now drop back to that graph I showed you for from Victoria, you can see the same thing has happened here, is that we haven't recharged the soil to slowly recharge the water, the creeks, and we haven't recharged the alluvium from the creeks. Most people do not understand that river flow is not runoff. River flow is groundwater flow and what's called interface drainage, that comes out from the soil. Floods are runoff, and our floods have increased substantively. So this is a good example of just quickly showing the science of it, that little thing called an E, which is supposed to be a P with a squiggle, but that's all right. My typing face can't produce that. That represents porosity, which is the space between the grains. It's either filled with air or filled with water. So alluvium has 30% airspace that can be filled with water. Weathered rock has less than 5% and fresh rock well less than 1%. So the difference between storing water in alluvium compared to fresh rock is at least 30 times. So when you're incised down into fresh rock, which is where the cutting stops once it gets started, it'll sit on a base of bedrock. That means you are storing nothing in your alluvium. That water available for your use for deep-rooted plants is gone. So let's look at landscape impacts on climate. So set grazing reduces diversity. And that in itself, without going to what trees do, leads to organic matter loss. And organic matter loss leads to deaggregation, so break up aggregates, which causes increased runoff, compaction, salinity during wet periods, reduced cover, which leads to dust storms. If you've got less than 20 species in your pasture, you're reducing your A horizon via deep deaggregation because you've lost a lot of the deep rooting species and the collaborative cooperation they do with both water and nutrients. You reduce your evapotranspiration, so you're leading to a less water cycle and an increased apparent drought. Note I use the word apparent drought. We'll hear from both Hamish and Niels later on, who are farmers, that currently in the areas they're in drought, but they're not. So the other farmers are suffering drought, but those two aren't, because they have a deep water storage they're accessing via a deep A horizon. Notice I don't call it a topsoil, because topsoil puts guardrails on your thinking. which you mean, oh, it's only the top bit, which is 6 inches or 250 mil. Whereas A horizon can be as deep as you can make it, and we can make it deep. So de-aggregation, i.e. a massive soil structure, increases runoffs, causes floods. It causes a loss of small water cycle, and it increases heats and frosts. So loss of production, but also exports heat that can cause bushfires off-site. The solution, and that was pretty grim for all those farmers out there to hear, is that there is unexpected consequences, things that we call adverse externalities are occurring from landscape. That's a grim thing to hear. It's a grim thing for me to have had a lifetime getting to understand. So we put together a solution base that addresses those 4 aspects that are significant. So let's look at the basic scientific principles for holding water at source. It's really very simple, highly scientific, really, really scientific. Get it in, hold it in, if it runs off, infiltrate it, then work for more rain. Okay, I'm being a bit facetious. There's a lot of science behind all that. But effectively, what you're trying to do is hold water at source, but not in structures. It's the landscape health song. It's about climate, soil, mid-slope and river. Why a song? Because a song, every instrument has to be tuned and operating properly. But more than that, every instrument has to work together. There's nothing worse than an instrument that's out of tune, but there's also nothing worse than people not being on the beat and singing the same song. So in all aspects, it's a good descriptor of the fact that each aspect has to work together and work well on its own. I can't go into it all, but I'm just going to start a little bit with the soil system that's needed, and it's interfaced with plant growth, and it interfaces with the climate. So if you delve down into the roots and you have a root system that has a healthy biome, that's to say the root feeds the bacteria feed the fungi go out and collect phosphate or potassium from the minerals, but also they go and collect nitrogen and complex carbon from lignin, cellulose and hemicellulose. They then feed it to the bacteria who feed them sugars. The bacteria take all that and get taken up by the root or directly feed the root, depending on the relationship. And you end up with a healthy root system. But the healthy biome has a connection between the mineral matter, as you just heard me talk about the fungi having to crack the mineral matter, but the mineral matter has a unique relationship with organic matter and living matter. So the organic matter sticks to the mineral matter and aggregates, and the biome forces it to aggregate by releasing glues. So having a healthy soil requires the 3 matters to work together, the mineral matter, the organic matter, and the living matter. And regardless of what you hear from others, no matter is more important than any other matter. Or should I say, no matter matters more than any other matter. How many matters can I throw in? And then from the soil or the plant, you have the interaction with the plant above. And multiple plants create an interaction that's able to maintain evapotranspiration cover, which impacts the climate. And the nature of the trees directly impacts the climate. And the nature, the spread, and what the trees do, and how they interact with the grasses, and the nature of the soil impacts the climate. That's a lot of science. We don't have time for that today, so that is in itself very interesting. This is a really difficult thing to understand, but I put it up because it is simple in its interpretation, but the physics of it's hard to get. So PF simply means the negative log of pressure measured in millibars. So that is how much suction you've got. PWP or WP's wilting point, it's at a minus 15,000 millibar, which is 4.2. on this scale of negative pressure. Field capacity, the point at which a soil drains, is roughly 100 millibar, which is 2. The bit in between is available for the plant. So if you look at it, I think, is my cursor coming out? Is that visible? Right. So you can see that this bit in here is plant available water. Now, the really interesting thing about all this is that when you deaggregate a soil, you push it to its ultimate particles, which is out to clay or out to sand. Sand infiltrates quite rapidly, holds virtually nothing, and drains it off to the groundwater, unless it's sealed. When you deal with clay, and a fairly heavy clay, it holds a lot. So you've got 20 of the total amount of water, which is represented down here. This is what's called the saturation point. It has 28 over 48. So you're dealing with a circumstance where about 54% or 60% of water in a pure clay is just not available to the plant. So when you look at what's available to the plant, you've got 17 on 48, so that's roughly a third. And over here you've got 6 on 40, which is about 14%. So in these cases, you've got circumstances where here, within 3 weeks of no rainfall, plants will fall over. And over here, within about 5 or 6 weeks of no rainfall, plants will fall over. Now, your granites will sit somewhere down here, and your alluvium and your basalts will sit up here. If you've got an alluvium, it will sit as a loam. So it sits in here because it's got a nice spread of pores. But if you aggregate, you end up with a circumstance where you've got about 32 on about 44. So you've got 75 to 80% of water that infiltrates the soil is available for the plants. So this is called the efficacy of plant available water or the system. So you can improve the efficacy by multi-species, and there's varieties ways of improving the efficacy. But that's only one part of the trick. The other part is to grow the A horizon, and that's pretty much what SOILKEE does.
Hey, Phil, just letting you know you've got 5 minutes.
Oh, okay. Well, that's we're slide 29 of 50, so that's good. That's what aggregation looks like in sand, in a pure coastal sand, where you can see the plant is aggregating around itself, stimulating the biome. That's what it looks in a dairy system on pure sand, where it's heavily aggregated and built the organic matter upholding it. This is a clay-based system. You can see the smearing here, which indicates it's over 35% clay, but it's well aggregated throughout the whole system. So you can see this has got very good aggregation. It is a multi-species pasture, but which is under SOILKEE, but doesn't actually show that clearly. If you add fertilizer, the aggregation building slows, stops, or reverses, depending how often, how much you add. So that means the sponge efficacy and thickness does not reach its full potential. So you've got to balance between how can you go about not adding fertilizer and maximize your productivity on your system. So I'm not going to talk about runoff because I think that'll be covered shortly by by Hamish. But I just want to look at, just so the farmers understand and the practitioners understand exactly what's involved. So I'm combining 2 data sets here only because we don't have a full data set under a low rainfall scenario. But this is the infiltration rates from Hamish's property under low rainfall situation at this point. We haven't quite got to this point yet. And this is the data of depth associated with SOILKEE at 1,000 mil. But what you're actually seeing is plant available water here is tons per water per hectare. So you got 141 tonnes. After 3 years, you've increased your infiltration rate, but you've also increased your aggregation depth. You've now got 1440 tonnes. So that means you've gone out from roughly 3 weeks to about 4 months if you don't get rain. After 5 years of SOILKEE, you're at 2,160 tonnes, and 8 years, you're 3,245. We've increased the depth, and we've increased the infiltration rate. So we're increasing how much the bucket can store, because if you've got 5 mil rainfall event, but the bucket's already full, i.e. you can't get more in, it's got to run off. So 2 things affect the runoff. At this point, you can probably last 12 months without rainfall. That last figure is not written up in my book, but most of the previous theory is. You can buy it from the Canberra bookshops or the bookshops elsewhere, so please go out. Like Hamish, so this is Mulvey and Daughter as opposed to Mulvey and Sons. So my daughter encouraged me to write the book because she felt the only way to influence policy was to write it. So I think there's a lot, just finishing on a couple of aspects. We covered just a bit on soil. We actually haven't covered how to influence the rest. And that can be influenced through what is done on the farm and to increase increase profit as well as productivity. And I suppose the farmer's goals, this is the point I'd like to leave, should be look to return the small water cycle through their pasture system and look to increase infiltration and thicken the sponge to ensure that they're resilient. And those two will increase profitability significantly. And I suppose that's a good spot to finish. The key quote comes from a guy called Chris Haney, who invented a thing which is a fantastic soil test, which is used by a lot of regenerative soil scientists and regenerative farmers. It's starting to have use in Australia. But Chris Haney, in talking about the soil, just actually said, water's the key. And that's where I'll leave it.
What a great place to leave it. Thanks, Phil. That was brilliant. Really enjoyed that analogy with the landscape health song and how you're connecting it to an instrument and the harmony. Because I guess as in nature, complex adaptive systems, nothing works in isolation, and how that system is really interconnected. And for function to improve and to sing, it all must work in harmony. Thanks for that. Hamish, take it away whenever you're ready.
Thanks, Aaron. Thank you all for taking the time to talk to us and see what we've been about. This is a hard thing to do in 15 minutes because what I'm going to try and compress here is 5 years. For those that you are technically minded, you need to understand I'm a classically trained chemist. I've got double majors in inorganic and organic chemistry. So I know quite a lot about carbon, its manipulation, and I have additional quals in the biological sciences. And I've worked in the dairy industry since the late 80s. I've seen massive change across the landscape, and the COVID period provided us with an opportunity that we decided we couldn't resist, which was we thought we'd like to build a little dairy farm. Maybe I could retire and milk cows. How hard could that be? So I'm going to introduce you to the impossible dairy. Let's see if I get this right. If I do, whoops, I need to do that first. And we're here, and you should have, do we have a main screen there?
Looking good.
Okay. So this is our program. The Impossible Dairy, we have described it that way because everybody that's heard about what we're doing has told us emphatically that it's impossible to do. So starting at the beginning, evidence-based agriculture. It's extremely convenient to claim there's no evidence to support the efficacy of alternate agriculture. Everything I'm going to present today revolves around understanding the multiple hydrological cycles that exist. No-till, regenerative, permaculture, natural sequence, keyline, these are all parts of the same approach. Rehydration. SOILKEE is about rehydration. This is our location. We're central Victoria. We're in the Shire of Mitchell. We sit right across the Great Divide. Elevation's 340 metres. The rainfall range for us is between 350 and 1200 millimetres in a given year. And there is an 80% chance of having 80% of that rainfall in any month. So I repeat, it is highly variable and there is no apparent sequence. The total area of our farm is 42 hectares with a grazable of about 38. Our target's 20 odd milkers a year. Agriculturally, the land is classified as degraded. We're in the Shire of Mitchell, which sits north of Melbourne. Kilmore is the nearest regional town. In the 1850s, Kilmore was the centre of hard wheat production for the colony of Victoria for export back to England. I provide you with a 2024-2025 rainfall figures. 25 was pretty mean. The front end of 2026 is not looking pretty. This is a pretty typical view in the district. In fact, this is pretty much what our place looked like before we got started. This is what the Bureau's got to say. From 1st of February to the 31st of January 2026. So you can see the rather substantial disparity between the southern and the northern parts of Australia. This slide is taken from a couple of months ago, but it's ahead of the summer. We are currently grazing, or at the time we were grazing 17 adult jerseys and 5 yearlings on 3.2 hectares. Estimated as 20 adults, so 380 kilograms each, 7.6 tonne. We've been grazing on the space since the 24th of October. We've done 26 moves of 1,230 metres square, or the equivalent of 520 grazing days. If the full 38 hectares was regenerated, this would be something of the order of 6,000 some grazing days or 308-day cycle. So what I'm talking about here is having intense groups of animals, relatively small, very widely spaced, grazing as we move around the property and developing it into a fodder-rich situation. So what's the catch? Why is this not easy to do? Phil has done a pretty good job of talking about infiltration, so I'm going to give it to you in 2 photographs. Same property, same rainfall event, same day. The spade in the ground on the right is in a SOILKEE paddock. That's about 4 years in. The picture on the left is water infiltration in an or non-SOILKEE, non-multi-species paddock. So even though the picture on the right shows it pretty tight cropped, we actually had just a couple of days before run the SOILKEE across and mulched, grazed and done various things that we've been doing. We've been doing the same thing in different locations, obviously. You can see the transition in terms of infiltration and moisture. So this is a zone where I've taken a photograph where there's a fair amount of transition going on. It's not obvious in the photo. So when we start to talk about the detail of this photo, in the lower left, we're looking at a SOILKEE first time May 25, to the upper right, SOILKEE fourth time in May 25. So we get a close-up on that lower left, and we see a pretty sad-looking pea plant. This is pretty typical of a year one result, phosphorus deficit, absolutely, and in this instance, coupled with moisture deficit. This was taken in the upper right, 750 mil deep. If you peer into the picture, you can see the growth. Exactly the same slide as we went back here. So I'll go back here. We're looking at the space to the lower left and the space to the upper right. Lower left, upper right, upper right. There are multiple species lurking in there. So this is my daughter, Ellen, standing in an area where it's probably the most advanced. We're 3 years in, no fertilizer, no chemical, no stimulants, just rehydration and the biology driving it. And the little pea plant on the left is exactly what was there. I have stood in this spot where Ellen is standing and had multiple people tell me to add phosphorus to this in order to get the pea plants to grow. We steadfastly refused. So this is a list of the people who I have found across the background study for this activity. These are names of people that are either being ignored or outright disrespected in terms of their knowledge and knowledge base. And I put it in those terms because as I have unpacked this, I've come to understand that underpinning regenerative agriculture and soil key function is a tremendous amount of science. It is both hydrological science and bioscience that needs to be understood. I cannot stress enough the work that Christine Jones and Elaine Ingham have done as microbiologists in unpacking this stuff at the early times, and the headwinds that they have flown against is just extraordinary that they continue to go. And this slide is a set of documentaries that you should be aware of if you're interested in this space, particularly the one from NHK World Japan, Carbon Farming from 2021. This is a particularly interesting documentary where they show the use of radioactive nucleotides transporting short-chain organic carbons into the soil column and moving resources from plants into other types of organisms feeding plants, fungi, all manner of things. So in our mind, SOILKEE's secret is it's about rehydrating the earth. SOILKEE is a way to harness the micro-water cycle to get the system to start to function. So that's us. We are impossible. We enjoy what we do on a daily basis. We bred those cows on the spot. It's a big thing to be here, Aaron. I'm delighted that you guys in the ACT have taken this on board. It's one hell of a challenge. Thank you all for listening.
Thanks, Hamish. Really appreciate that. I guess now we can probably move to some Q&A. If there's any questions that people have, please feel free to turn your mic on, come have a chat. Otherwise, put them in the chat box. Otherwise, I've got a couple of questions here that have been sent in prior. Might be for you, Niels. We've got a question that said, can the SOILKEE be wet or dry hired to be used up here in Canberra? And then also as well, and some advice on what is an entry-level seeder, new or second-hand, that would be appropriate to be used in Canberra that can handle our sort of conditions. Niels, I think you might just be on mute. Yeah.
Yeah, like with dry hiring machinery out, we haven't ventured into that. It's just another hassle that we aren't keen on. But we do a little bit of contracting and stuff. That's about our main sort of experience for people that are wanting to dabble. And like we tried all the different seeders. Lots of our farmers that have been trying different seeders as well. They tend to head off, and sometimes they'll do 2 or 3 years of trying every seeder that they can, and then they come back to the SOILKEE system. So it's not so much the seeder, it's the sheet composting effect and the diversity of soil conditions created by the SOILKEEs as it plants seeds. And they don't have to be multi-species, but multi-species you get a bit of a benefit from that as well. But it's the sheet composting effect that's feeding the microbes, enhancing that function in the soil by feeding them. There's sort of no other system around that feeds the microbes as well and as diversely. So yeah, that's the main thing that we've got around the SOILKEE system that is unique to it. And you know, that's sort of the story where we have to get the message across what you can achieve from it. And these few farmers that are putting together now 4 or 5 years in the whole farm, you know, the financial returns on that are very significant. So that sort of package put together is the understanding that why it's sort of a good approach, I suppose, and the science coming behind it just helps that support. Yeah.
Great. Phil, I just noticed you had your hand up there. Do you had something to add?
Yeah, it's actually picked up in a following question, which is why I took my hand down, having seen the next question. But the wet or dry hire triggered something in my mind, is that SOILKEE has been slow to work or hasn't worked successfully in some people's minds, and in the early days. And it took Neil's family a while, but then I had to look at the science of it to work out it doesn't work when it's too wet, and it doesn't work when it's too dry. And part of the reason is to do, Neil's calls it a mulching effect. I take it a bit further than that, but to do with how it stimulates the biome and the action it does between the interrow. And if it's too wet, it smears and drops the seeds in and doesn't quite cover as well, and you end up with rodent and ant removal of seed and seed exposure. But you also don't fling it across the interrow. If it's too dry, it's flung across the interrow, but it blows away and doesn't cover the mown or grazed material. And the concept is to actually graze a few days beforehand or mow beforehand, so you can drop grass on the interrow and especially the straw, that then you're able to then cover with the flick across. So if you're not flicking across at the interrow, you're not achieving sometimes the optimum growth potential. And that, I think Niels would support me, and that's been a slow learning, that sometimes it's too wet and sometimes it's too dry, and how to address when to do it is important in your rotational system, as well as looking at mowing. So I'll defer to Niels on that, but there is a lot of early people who adopters who ran into trouble, and it was working through that trouble, understanding what is the optimum time to do it. Preferably knowing that you're a few days ahead of rain, and what the forecast's like is also quite useful.
Yeah, I think Hamish's experience with how the peas started off is quite common when the soil function isn't quite supplying the nutrients, and that 2 or 3 goes of the sheet composting effect really widens that planting time, and the moisture restrictions are widened as well. So it's once you've got function back into your soil profile, and it's depending where you're starting. If you've got a bit of function in your soil profile, it's not so narrow the planting time. But if you're fairly hard, fairly compacted, fairly non-functioning soil, your ideal time is around that ideal moisture level. Yes, it's a better off start. You get a better result. But even when it's a half reasonable result, 2 or 3 times, it improves each time, and then away it gets going. So yeah.
Right, thanks, Niels. And g'day, David. Just noticed you had your hand up there. Did you have a question? We'll go to you and then go back to Hamish. David, I think you might be still on mute as well. Otherwise, you can chuck in your comments in the chat, and I'm happy to communicate them as well. Might just pass to Hamish quickly. David, if you want to chuck your comments just in the chat. Thanks.
Yeah, and I was just thinking about that little pea plant. We make those little pea plants work. Vetch also behaves the same way. All the legumes work pretty hard in the initial stages, and the hardest thing for everybody to get their head around is the fact that what you're really trying to do is re-engage the biological systems as they existed. So the human tendency is to want to find an interference. And once we understood that the application of fertilizer across the surface was interfering with the biological pathways in the cellular structures and essentially stopping them from doing what they would do normally, the first thing you have to do is wait for the existing available surface interference to be taken up. And then you have to allow the biological systems to be in place to start actively sourcing those materials, phosphorus and so on. And that takes a little time. And without the compost present, you don't have fungal action. And without the fungal action, you don't have recovery of resources, because the fungal function is to essentially digest and recycle the necromass. And it's the necromass that contains the bulk of these elements. Once you get that functionality, then you start to see root depth being driven to depth over time. And I will make the point that our soil pH at surface started at 4.5. We now sit in the space of about 6.7, 6.8. And that's solely through organic process, no additives. So we're really very focused on making the biology do the heavy lifting.
Fantastic. We also got another question just in the chat too. I'll throw out to all three of you. Could you please connect the use of or abstinence of chemical fertilizer regarding the rhizosphere around the roots and emerging seedlings?
Oh.
Okay, I'll jump into that one, Hamish. Modern seeds, particularly ryegrass, have been bred to produce a lot more photosynthate to be converted to simple carbohydrates in the leaves. The more traditional material had roughly 30% of photosynthate goes to the roots and out of the roots into the rhizosphere. To feed and there's a whole range of photosynthates that are emitted, and some of them are chemical communicators. And what they do is they encourage the bacteria to go out and work with the fungi to bring back nutrients. And there's a thing called rhizophage, and the roots suck in the bacteria and strip the cell wall off them and kill some of them and spit about 20% back out again. So that's how you transfer your nitrogen and your potassium. Your phosphate is a little bit harder. And though I do agree with Hamish, is that there is a necromass, which is degraded, and phosphate sourced from that. After many years of super use, right throughout the Monaro and up into Canberra, and it's probably put out once every 3 to once every 5 years, the phosphate that gets put out, about less than half it goes to the plant. Roughly 25% goes to particulates and gets washed into rivers and the like, and 25% gets stored permanently in the soil. As well as that, basalt, and years ago I told Hamish he was on one of the best soils you could possibly be on, and he looked at me in absolute disbelief and said, it's degraded. I said, yeah, it's still one of the best soils you could be on. Basalt has lots of apatite in it, and apatite is an insoluble form of phosphate. Black granite also contains both phosphate and lots and lots of potassium. So your parent material decides how much totals you have. Now, if you have high totals, but it's insoluble, and whether we put it in historically or whether it exists in the parent material, the communication between the fungi and the bacteria and the root was such that that evolutionary biology exists so that the plants stimulate the bacteria, and the fungi then put out a glue to aggregate to make the roots easier to penetrate. That glue then makes the journey shorter to move from the fungal hyphae to the bacteria to the root. So the constant aggregation, so a series of fungi create a glue of which the group name is glomalin, though that particular substance is only made by one type of fungi. But many fungi make glues that aggregate. And these glues do last in the soil for many, many months, as long as it doesn't go anaerobic. And the function then is to allow several other types of bacteria, fungi, several other types of fungi, of which there are two types. One is a saprophytic fungi, which eats degraded material, particularly breaks the very hard bond associated with aromatics, then breaks it to heterocyclic. But there's also another type of fungi that specializes in producing acid, and it solubilizes the phosphate, which is hard to get. And it's members of the penicillium family do this, and they produce the acid and they spot put it directly on to the apatite at absolute nano level and release the phosphate, which then goes to the cell wall of the bacteria and then gets shunted back by rhizophage to the root. It takes roughly 2 to 3 years to fully turn this system on. So the plant is not going to waste photosynthate if it's given for free. So if it's got nitrogen, phosphate, and to a lesser extent potassium, readily available in soluble form, why waste energy in building a system to attract to yourself? So it takes a while before the available phosphate's gone, but it also takes a while for the poor old plant to go, I got to put energy to this, I got to work, I've got to redirect all my systems to producing photosynthate. I've got to build a whole series of chemicals that I may no longer have the genetic code to do. So epigenetics comes into this because the first lot of legumes and clovers, those that survive after the first year, put out a bit of seed, not a lot, just a bit. And by golly, they look bad. They're purple and shriveled and don't get going. The second year, they look a bit better. And the third year, they're absolutely ripping out. And that's the third generation. So it's the genetics have now adjusted to the system, and the microbes are now appropriately stimulated. And you don't need to go the full 3 years or so that Hamish did. There are now systems that we can do that can accelerate it a little bit. But certainly the first year is a bit of a shock to everyone when they go, hang on, my legumes are looking carked. And we go, yep, that's what happens, because the whole system has been used to being, spoon-fed steroids like a junkie in a gym. And it takes a while to build muscle once you get off the steroids. So recover the biome. It can't be done in one season, but it can be done quicker than 3 seasons with the information we have already.
That's great. Thanks, Phil. David.
Yeah, I've got my mic working now. So
Brilliant. Go right ahead.
My battery was running flat, so I had to find the plug-in. My question is in relation to this regeneration, is where you have pasture that has a lot of weed, or, for example, around in the ACT or our area, there's a lot of love grass. What is happening in relation to that? Is that being mulched down and then the pasture renovated being put through, or is the love grass being dealt with by spraying it out? And then, of course, the other thing I was just thinking of is that if a lot of super's not been going out, or you haven't been putting out super, and you do a soil test, you find your phosphorus levels are low. And so if you do put out super, you'll get an instant response. So they're my questions, just in relation to, well, okay, to do a total pasture renovation, obviously there's a huge cost involved if you're going to do, a significant area versus the alternative.
Okay, I'll respond. Thank you for that excellent question. When you look at Olsen or Bray, or even a lactate P, which is what I tend to prefer than Olsen or Bray, you're not looking at total P. You are looking at what's considered more available P, but it not necessarily is the case. So if you haven't been historically putting out P and you do put it out and you get a big response, the question comes to the nature of your pasture and what is your parent material. There is absolutely no doubt that Australia is P deficient overall, and we have some parent materials that are very deficient in phosphate. The solution is not to put out available P, but to put out a combination of rock phosphate and crusher dust from basalt, together with, and it's not yet commercially available in Australia, but certainly rock phosphate is, together with Penicillium bilii, which is a particular fungi that actually attacks rocks to release phosphate. If you put out readily available P, you kind of shut the system down a little bit. And if you put out salts of acids, i.e. DAP, superphosphate, MAP, most of the commercial phosphate mixes, you are putting them out as salts of acids, which means you acidify your soil. You then have to lime. And if you're not correcting for the biome in your liming, then you degrade the system with time. So the problem with phosphate addition is that it does give you a quick fix when it's in the highly available form. There are some available forms that aren't acid, but they're much more expensive and people tend not to use those. But most of the readily available forms are salts of acids and they acidify. So you end up not only short-circuiting the system to go and find P, but you also acidify the soil at the same time. So that's why I'm a bit of a believer in slow release P that encourages the biome to develop. But I'm also a great believer in looking at a total nutrient of not so much just available nutrients, because you really want your biome to go and crack it. Finally, there's a thing called economics. And sometimes you need to step backwards for a step in terms of your natural capital to ensure your financial capital is safeguarded. So it doesn't mean in all circumstances I would not I recommend the use of any salt of acid P, available P. Sometimes there is a reason to use it and you will suffer a penalty in coming years, but you understand that year you do need to get a quick hit. Is that the sufficient answer, David?
Yeah, and then I was just wondering in relation to, like if you have, for example, it's predominantly native pasture, but we have the problem of love grass, which infiltrates the natural pasture, and you get spots of it, and sometimes you get a large spot of it. Are you just mulching that down before you put a renovator through it, or are you poisoning it?
I might answer that, Phil. In comparison, this photograph that I put up before, I'm not sure I can put it up again, but we were predominantly bentgrass and phalaris. Bentgrass is pretty invasive, creates a pretty stable mat, thrives in a pH of about 4.5 to 5. So whilst I'm not particularly familiar with the love grass, the approach to dealing with the bentgrass was to sow into it and allow the environmental conditions to change and transition to a point where the bentgrass itself is no longer viable. My understanding is that works across Juncus, which was in that photograph I showed you earlier, and Phalaris behaves the same way. So I would have thought there was no reason that the love grass wouldn't go the same way.
Okay,
in fact, it applies for all weeds. A weed is an opportunist, and it's an opportunist because the conditions suit it better than the pasture you want. So it's a matter of saying, well, let's change the conditions of the ground so the opportunists aren't able to colonize. And one of the things that a weed is very good at is rapidly growing a biome to suit the conditions. So in the case of Hamish's, it was to exclude aluminium because the pH was low, which was actually toxic to most of the rest of the pastures. So usually with time under multi-species pastures, under SOILKEE, or tends to completely eliminate weeds. There are some special techniques associated with getting rid of serrated tussock, but it's worth bearing in mind that if you've got small patches, then chipping to remove is one of the best, but ultimately a weed tells you, just as urine patches or unbroken down manure pads, they all tell you that your system is out of order. The same as floaters, rock floaters in the paddock. They're all saying that your system is suffering and it's communicating to you.
Yeah, I guess in relation to love grass, it goes where there's low fertility. So the argument, I guess, would be that if you increase your fertility, then obviously that's going to reduce the love grass or outcompete it. So
Yep.
is a hit of phosphorus on it going to either help the other species or then make it even better if you say, okay, go down this route that you're suggesting?
It depends.
I think it'll slow you up. That's my view, based on what we've seen. I think if you interfere with the system has a recorrect time wrapped around it. Might be 1 year or 2 years. But if you continue to interfere with it, it won't correct.
So I might just go to Jared, but if you don't mind, Jared, I might just take the time just to introduce what we're doing here in the ACT in collaboration with Niels and SOILKEE. So through the Australian Government's Climate Smart Ag program, we're really lucky to receive some funding to do some research here in the ACT. And that's really looking at multi-species pasture cropping as well as time-controlled grazing. We're incredibly grateful and very lucky to be able to work with our ACT farmers, 6 of them, here to explore these techniques and to actually put some data behind this over time to accumulate climate, pasture, soil health data over time, looking at soil moisture changes as well. We've even pairing up floristics and understanding how the pasture composition changes over 4 years. So this is a proper research trial, and we're really looking at what are the individual and combined effects of time-controlled grazing, multi-species pasture cropping, as well as some biological amendments on soil health, function, and pasture productivity in dryland conditions here in the ACT to provide that context of what's going on here and what's possible in transitioning different methods. So there's a lot that we'll be capturing, and it's very exciting, and again, incredibly grateful to be able to work directly with farmers in this and collaborate with them. Jared, I'll just pass to you.
Thanks, Aaron. And I also just want to thank you, Aaron, for organising this. And it's really exciting to be working with you, Hamish and Niels and Phil. I guess you pretty well said what I was just about to say, is that we have 6 very brave and generous farmers who have signed up to a 4-year trial for us to be able to undertake a significant science trial. And I just want to reiterate that that it isn't just about the SOILKEE. It is in SOILKEE in harmony with the type of grazing system that Hamish is utilising on his Impossible Dairy, which is really working on making sure that there is the right kind of density of livestock, which is quite a high density for a very short period of time with adequate rest periods. And Aaron has been working tirelessly on doing pasture assessments to know when the cattle are to go in and when the cattle are to go out. And we do have and Aaron's already mentioned this, we do have a field day coming up on site with the SOILKEE, looking at we're sowing for the second year, and very much understand what Hamish and Phil were talking around. In that first year, it wasn't looking fabulous. Mind you, it was looking pretty good by even just being able to change the rotations. And certainly we saw quite a variable result from it. But I would encourage any farmers who are interested in this to have a look. This is a serious science trial which is being undertaken with Southern Cross Uni, and we're doing absolutely comprehensive soil testing and floristics on this. And so we're wanting to make sure that the science that has been observed in Victoria can be extrapolated into our ACT drier context and with our quite infertile soils of the ACT as well. So I guess I just wanted to reiterate that we do have this trial going on, and we have 6 farmers who we're incredibly grateful that they're willing to put aside a piece of their land and to work with us, which is outside of their normal routine to be able to do this. But we're hoping that this is going to be delivering results after the 4 years, which will help to inform ACT farmers as to real science to improve soil structure, to improve our rehydration of our landscapes, and to reduce the need for expensive chemical and amendments in general across our landscapes. And we know that the profitability in farming is getting tighter and tighter with the cost of inputs, and so this is a real issue. And David, your issue with the love grass, we have specifically chosen sites which also have love grass as a major component of this, so that we can see what the results are and how that then will play out in the longer term. So I'll be quiet, but I just wanted to congratulate you guys and thank you so much, Aaron, for the work you've done in putting this together today as well. So thank you.
Thanks, Jared. That's great. And we just got one last question before we begin to wrap up for today. So Stephen just put, do you stick with the same mix of seeds over the years of sowing? Hamish or Niels? Probably directed to you.
Yeah, I suppose I can talk on that a bit. The seed mix, we change it for the summer season for the summer crop and for the winter crop. And the main thing there in the change is millet for the summer and rye corn for the winter. We're finding very lush feed created very quickly, and we need fibre. So the millet and rye corn give you early fibre for grazing, And the seed mix is, probably over 20 different types of seed in there. The conditions are changing so much, the pH is changing so much as you improve your soil profile, different things want to dominate. And it's like, you can see the phosphorus coming available, so the peas are growing quite well. And it's the same thing with the love grass and the bent grass. When you're getting low phosphorus availability in your soil profile, the grasses that can handle, they're low production grasses, but they're also can handle dominating the pasture set because of low phosphorus and low pH. So as you increase your phosphorus availability, like in virtually all the trials that we've done, we've had an increase of 100% increase in phosphorus over 3 planting applications over 3 years in trials. So you're doubling your available phosphorus 3 times through with SOILKEE, and that's evident showing in those P photos of Hamish. That's what you create. And the pH is, like on our property is probably the main one that's had the pH change over the whole time period, like of 10 years. We've gone from like a 5.2, 5.3 pH up into the high 7s without applying any lime. So it's the biological correction of the pH and nutrients coming available. So the seed mix, we keep it consistent because it covers your chemistry changes, your biological changes, your moisture changes, and your seasonal changes. And we've sort of learnt that the mix that we're working with down here seems to give a quite good result virtually every time it's planted. So that's the reason.
There's a big deal here in terms of naturalisation of seed as you go through the cycles.
Yep.
We had not expected vetch to naturalise in the way that it did, and we also observed bent grass become actually fundamentally productive through the cycles of the SOILKEE. So it actually stimulated some response. So there's all kinds of things going on. You need to really be paying attention.
Fantastic. I think that's a really nice natural end there. Thank you, everybody, for your participation in today's discussion. That was incredibly fascinating. Thank you, Niels, Hamish and Phil, for all your wisdom and presentations today. That was fantastic. We will be sending out... Yes, sorry, Hamish, go for it.
Aaron, I can see, I think it's a Ross Truton is looking to ask a question, but his microphone's off.
Yep. Thanks for that, Hamish. There's a little bit of time,
thanks,
Ross,
Hamish.
if you want to go.
Just very quickly, my question's for Niels. Niels, have you had any experience of using your machine in the inter-row spaces in a vineyard, a grape vineyard?
Niels, your microphone's off.
Yes, we've had some inter-row stuff, but it wasn't in grapes. It was in actual blueberries and stuff like that. And significant increase in nutrient availability in a short period of time. They were looking for shelf life of their product and nutrients coming through. We've just started the process, and I think the first half dozen inter-row machines are coming out now. Hamish has got all the drawings sorted that they'll start rolling out shortly. So that's one of the things that the inter-row for flavour of the grapes, having the nutrients highly available to the root systems of the soil that it's planted in, seems to be a sought after thing for that industry. So where the fruit flavour really comes from those nutrients in the soil as well. So I think that'll be a fairly large take up because of the a lot of the problems that come through with that type of industry is, like that they need antifungal stuff on there, where if you've actually got the nutrients balanced, there's less requirement for that, less problems in the system. So, and that's like all of what we've been doing. There's no intervention with sprays. It's the nutrients start to cycle, and then the more productive, or the bent grass becomes more productive, and then the other grasses will come over and dominate over the bent grass. Kikuyu down in our area, it was dominating in a few patches. We've 4 or 5 times through that greatly reduced, then our normal ryegrass came and dominated, which is virtually doubling the production for that area. And it's maintained that. So it's the nutrient cycling maintains the dominance of the species that you're prevalently after. If they've got the nutrients, they'll grow. So, yeah.
Thank you.
Thanks, guys. Well, yeah, we'll wrap it up there. And just for everybody's information as well, we'll send out an information pack with this recording, plus some details on the upcoming event for the demonstration day, where Niels and everybody will be up to go through the SOILKEE live in action. So looking forward to seeing you all there. If there's any other questions, please feel free to shoot them through via email to us, and we can connect you to Niels, Hamish, and Phil, as well as we'd be happy to support you in your learning as well. Alrighty, guys, thank you very much, and enjoy the rest of your day.
Thank you.
Thank you.